Well, good afternoon. Today we wanted to meet with you guys to discuss streamlining production with automated nesting in SOLIDWORKS. We appreciate you joining the webinar. Presenting today, we have Jorge Ahumada. He's our CamWorks specialist, and I'm Sam Scholes on the SOLIDWORKS and CamWorks sales. So first, we want to talk just briefly about GoEngineer for those of you that may not be familiar with our company. Then we're going to talk about NestingWorks, and we're going to show a live demonstration. We expect this to be about 20 to 30 minutes. If you have any questions, please put them in the question box and we'll address those. And thank you for your time. So first of all, GoEngineer is headquartered in Salt Lake City, Utah. We have 40 offices across the United States, and we specialize in product solutions from SolidWorks, Stratasys, HCL Technologies, that's the developer of CamWorks and NestingWorks, and we also represent Creaform for 3D scanning technology. We're the #1 SolidWorks reseller worldwide and one of the top partners for CamWorks. In addition to selling these tools, we also provide expert training and implementation services to help ensure that customers are successful. Our mission is to help companies enable the use of new technology, right? There's a lot of companies that can benefit from these tools, and we're set up to help you guys adopt them and help reduce costs and risk and the time required to go live. That's our goal, and this is a solution that we're excited about because it's helping a lot of our customers do some exciting things. As I mentioned, GoEngineer is headquartered in Salt Lake City, Utah. We do have offices all over the country, and there's several other states that we represent as well. So we have a large presence throughout the United States, and more recently, we've actually moved into Canada for some products as well. So let's talk about NestingWorks. So NestingWorks is an add-in for SolidWorks that provides automatic nesting for parts and assemblies to optimize sheet stock for production. So we have customers that are using this for wood, for plastics, for metal, and it can be used with any CAM software or any downstream production tools. So it's not just limited to SolidWorks integrated tools. This is based on HCL's world-renowned, really a very popular NestLib algorithm. It's known as being one of the fastest and most fully featured nesting libraries available. And the objectives are pretty clear. We're trying to maximize material usage. We're trying to optimize designs for production. And we're trying to save on production material costs. A lot of customers that we've talked to are doing nesting manually in SolidWorks, which is very time consuming. And NestingWorks eliminates all of that. It's very automated, as we'll show in the demonstration. A couple of the features and benefits are it does offer true shape nesting. So it's going to orient those parts. It's going to provide simple nesting. It has user-specific grain direction. Many customers are concerned about grain direction for wood. That can be specified. We have part-in-part nesting, allowing you to really maximize material usage by fitting smaller parts into open areas and cutouts. It is associativity to SolidWorks as well. So when our designs change, the NestingWorks layouts will change as well. So again, saving us additional time. We can also sort parts based on material thickness. Many customers generate designs that are multiple materials, multiple thicknesses, and NestingWorks can account for that. And then as I noted before, we do have compatibility with downstream manufacturing tools. So if you're using a different CAM solution, that's okay. You can use any CAM software downstream with this product because what we're creating with NestingWorks is a 3D SolidWorks assembly. So it's very easy to work with other tools. And now we want to go to a quick overview, and we're going to talk about the software and show a demonstration. So I'm going to have Jorge switch over to SolidWorks, and we'll take a look at a live demonstration of NestingWorks.
This is Jorge Ahumada. What we're going to do is I'm going to take you into the high points of the NestingWorks. And we were talking about compatibility downstream, compatibility upstream also. It has a lot of tools built in, a lot of technology. And it is used by a lot of people that do the sheet metal, all of the sheet metal development in SolidWorks. And usually the very first question we get asked is, well, what if I did not do my sheet metal development in SolidWorks? it will offer some tools, an intelligent unfolder that can be accessed manually for you to actually take apart, and we all know how this is. All we see is an imported, no intelligence on it. But the unfolder can actually work with it as long as the bends are there. And of course, we have to tell it. On this part, you could do interactive. In the vast majority, you can just go with the automatic, where we say, take a look at this, figure out what everything is so I don't have to pick the faces. And we tell it how we're going to do this. Are you using a K-factor? Are you using a bend table? And if you have your own bend table already developed, this button would allow you to do it. And this is what it does. When you accept that, it makes the reverse calculation, fills out any punch or formed areas, and it gives you what will be the true blank that you would have to cut to make that part. So we can also keep this and use this as a tool for imported parts, because sometimes we get the entire set of parts from a customer that might be working in a different system or doesn't send the complete set of data that we might want. It's okay, we can deal with that. Now, with that said, we can now take a look at how this operates. It can operate either by grabbing an assembly, or it can operate if we put all of the parts that we want to nest in a folder. And if there is an assembly where all of these parts get put together with hardware, nuts, bolts, it's okay, because it will discard in this first mode of operation the assemblies in there. We don't even have to bring the parts. We can just go straight to the nesting and nest by folder. What folder do you want to do? We just navigate our disk and we point it to the folder where we might have those parts. It will read all parts that are sitting there. It will access the sheet metal data if it exists on it. And it's going to stop and say, look, you have this part that does not have any. It has already done the unfolding. But you have this part that does not have any bend data. What do I do? Do you want me to run the unfold? And this window that you see here was invoked automatically by the system. It is the capability that you can access on your own if you want to reverse engineer the part. So all we have to do in here is go OK. So if you look at the picture, it's going to say, oh, that's a flat part. Here's the set of parts that you have. How many of those do you need? I would like to have 2 sets, and it alters every single one of those, and you can control it manually. It is a job-based nester. It is designed to do it on an as-needed basis as the requirements change, which in some operations change by the hour. So it needs to know, as a job-based nester, what parts are you doing? How many of these do you want? It needs to know what is the material that we have here. And we have a library, user customizable, that contains what the system calls standards, but we can also give it custom, DXF files of irregular remnants from the past, sketches inside a part or an assembly. So we will just give it one of these. So you have a total of 5, use however you want. It does have a sheet forecaster. If we present it with a whole bunch of them, it can actually look around and decide which one will be the best. We have part data, we have sheet data. It does have the option to deal with multi-head routers if you have them. And here in the options, we just tell the system the basic parameters of keep a 1/4 of an inch between parts, do the fast nesting. We can also generate remnants as sketches, and we can also tell it what type of shape, true shape. square shape, minimum, whatever. And that's really all you need for the nester to do its work. Once you go in here and you say, let's go ahead and nest that, he goes, whoa, whoa, whoa. Here is a problem. You do not have sheet stock for this part. Why is that? Because it also separates by thickness, and somebody designed this part as a different thickness than what it needs to be. It will separate by material, by thickness, and allow us to control it that way. Or we can go in here and tell the system, don't worry about it. Put everything on the same. So then it goes and it just throws it in the thing, however many we let it do. However we see fit. All of the control is here to automate this. A lot of these controls can be saved. So you can go back and take a look at the part and go, well, on this one is going to have a protective polyethylene film. I would like to have the other way. You just flip the part 180 in the nest. I change my mind. I would like to have 5 sets. Same process, new nesting. And if this is all you're doing with the nesting, this is really all you have to do, because from here, you can tell the system, look, just write me a DXF, I'll put it on a memory stick, take it to the machine, and the machine can take it from there. If you do want to use some of the CAM tools that are integrated like CAMWorks, you can tell it, get me an assembly of this, and it will put it into an assembly. It will ask you if you want all of these parts to be known to CAMWorks to be machined automatically. And at this point, you just went the extra step to tell it, I'm going to go to the machining site. It will give you a quick report. What did you ask? How many we did? What is your current overall utilization if you're going to do this on this sheet? And that's really all this is. This needs to do the work. You just have to specify the parts. You just have to specify the stock that you're going to be using, amounts, degrees of freedom, and it can do then the complete nesting, even if it is irregular shapes. We had said we can also start out of an assembly. So you might have something like this. Where you might take a look at it and say, yes, I need to cut this out of some material, make it like a kit, because this is what gets packaged for sale out there. So you have all of the components sitting here, have the whole assembly, process is the same. Whether you start with everything in one folder or in an assembly, you can just let the system know, grab all parts, isolates, checks marks, puts them on the list, and then it launches the user interface. How many of these do you need? I just need one. They are done out of 3mm plywood. You probably have seen this in the stores. What is my raw material? You're not limited to just what you have defined previously. You can tell the system this is a custom, and it has a 300 by 300 millimeter. It's about 12 inches. We work on both. and what spacing do you want between those, whether it is on every edge or whether you just say put this to the edge. That's all is needed. Once you tell the system, go ahead, let's go ahead and do this, it runs through the same thing. Given the complexity of these parts and given all of the degrees of freedom we give it, it is going to take a little bit longer to go through it. You will see the screen flashing a couple of times. And once it has come up with it, it will just present it. And if you are doing very complex parts, you do want to have most of your splines. If you can simplify them, that would help. So it goes through and it goes in the material you give me to make the kit. It looks like this. And you're pretty much done with that. So whether you're doing your basic wood or sheet metal, the process is the same. You could have things like something that we can relate a little bit better. We have a sofa frame. It can be something that is completely parametric with a lot of configurations. It's really not a big deal. And the reason it is called true shape is that it is going to keep the shape of the part complete with the dog bones, because you have to cut those. So we're going to create the next job. We're going to tell it, here are your parts. And this part, because it was done and a lot of the work was done in the context of the assembly and some of the parts were already designed at an angle, it will show them at an angle. And depending on the step angles that we have in here, depending on how many times we want to try to rotate the part to do this, it can go through and pretty much just give it a material. If the material is already present, it will tell you. You don't want to add it as a duplicate, we already have it. We'll do 1/2 inch, we'll do 1/4 to the edge. We don't need to generate remnants. And we do the fast nesting. So it does its work and now it's pretty much done, however many you ask it to do. It is possible for the nester also to work with an assembly that contains assembly in assembly. It will just drill down to all of those. So it is very basic. A lot of the interaction becomes second nature, and it will get you pretty fast to the point where you can do something as complex as this in a few minutes. Now we do offer the training and we will take you through all of the other controls based on what your needs are. And as we said before, if you do have questions, write them in the interface of the webinar, and we will answer them after this.
Well, thank you, Jorge. That was a good overview of the software. We just want to touch on a few of the capabilities and advantages of NestingWorks. With NestingWorks, we can increase material optimization as much as 60%. We can improve our utilization of materials, right? Reducing scrap and waste. We're definitely increasing productivity because we're not doing this manually, right? Nesting these parts manually would be hours of work. So as you guys saw, the automation piece is very fast. And we're really also, because it's tied with SOLIDWORks, if there are design changes, that automation piece is also going to save us time, because when the design changes, our nesting layouts are going to update. So it makes it very easy to do this production and to streamline things. There were a couple of questions. First question, Jorge, is can it nest parts inside of cutouts of larger parts automatically? And yes, that's what we refer to as part-in-part nesting. So it is capable of doing that to further optimize material usage. And then the next question is, if we're using a laser, does NestingWorks have the ability to add tabs or micro joints to prevent those parts from falling off the sheet? Are those tabs positions customizable? Do you want to address that question, Jorge?
Yes. It is not going to add automatically the tabs, the micro joints, the shaker joints, the shaker tabs, whatever the terminology you want to use. If you do pass the information to CamWorks, a heavily customized post-processor can drive a laser, and the contour milling operations of CamWorks will have the options of tabbing the part. That will be a capability of the CAM system. It will not do it at this level.
There's no other questions at this time. If there's anything else that you guys are wondering about, please let us know. The last slide or two that we wanted to touch on is just largely on support and training. As Jorge mentioned, this is a product that we teach training for. Many customers do pick up on the tool very easily, so not a lot of training is required. But like with all of our products, whether it's a SolidWorks or a CamWorks solution, we have expert phone and online support available. It's from 5 a.m. to 5 p.m. Pacific time. So we have lots of support resources. We offer professional training on all of these products, including all of the SolidWorks products. We also have an extensive library of online resources in our knowledge base. We actually published over 1,000 new pieces of content last year alone. And so our YouTube channel and our knowledge base are constantly growing to provide you guys with tips and tricks and additional knowledge and information about these tools. To highlight where you can find us, we have a great email newsletter. I think it comes out about once a month with great information on all of these products, as well as new technology. You can find information about GoEngineer training on our website, and please subscribe to our YouTube channel. We're also on the typical social media places, LinkedIn, Instagram, Facebook, and Twitter. So follow us for more information about upcoming webinars and events, as well as content, like I said, on tips and tricks and other things. So we appreciate your time today. If there's any additional questions, please let us know, and you can reach out to us directly if there is. Have a great day.
Thank you for the time.